Now, we need to move to the third and final contributed talk of today. Right now, we have the pleasure of listening to Safia Bano from University of Karachi, whose talk is titled A Defense of Placeholder Essentialism. So, Safia, you have 20 minutes for your presentation. When you have spoken for 10 minutes, I will interrupt you to let you know that you have 10 minutes more. So, the floor is yours.
Thank you. This is a work in progress, and so these are actually preliminary thoughts. So I would definitely welcome comments and any suggestions. So today I will defend a version of essentialism, which is called placeholder essentialism. Now, placeholder essentialism, the whole problem of placeholder essentialism is actually derived from the problem of natural kind essentialism, which is actually Kripke-Putnam's view of semantic essentialism. And as is well known, Kripke-Putnam's view has been heavily criticized by many philosophers of even language and philosophers of science, and philosophers of chemistry have also criticized this view. So some philosophers of language have come up with a modified form of an essentialism, which they call placeholder essentialism. Now, placeholder essentialism is a variant of psychological essentialism, and it maintains that humans are predisposed to categorize things based on a certain underlying structures. On many occasions, we are unaware of that actual structure, but it's assumed on our part that such a structure exists, and it is discoverable by scientific inquiry. The interesting thing about placeholder essentialism, or the thing which I think makes it very suitable for science, is that it does not make any a priori claims about what kind of a structure we are going to find. So your structure can be very much complex. But placeholder essentialism has also been criticized. Specifically, it is claimed that I'm actually referring with respect to chemical kinds. It is, if there are any chemical kinds, it is argued that placeholder essentialism is actually a preschooler cognitive bias, and science does not work like that. And specifically chemical kinds, they do not have any underlying properties. Therefore, it is not suitable for science. And even if we have such dispositions or intuitions, they are not very important for science. And then there is another criticism that specifically scientists or chemists, it's not actually their aim to find out essences. Rather, they are more interested in, for instance, when it comes to chemical kind, they are more interested in how to individuate a chemical kind, how to identify a chemical kind, rather than how to describe what is a chemical kind. Now, my argument is that I am actually defending a version of placeholder essentialism, and I am not claiming that all our scientific kinds are suitable for placeholder essentialism. I'm not claiming that, but I am claiming that at least there are some kinds, specifically in chemistry, which do fulfill that criterion of essentialist intuitions. And I am taking a chemical kind element as my example. And then there is a disclaimer that the microessentialism I am favoring is not at all traditional microessentialism with its a priori conditions. Rather, I am actually defending macrostructuralism as it is advocated by Henry. So the question is, can we actually present a macrostructuralist account of element? I think, yes, it is a very good candidate for microstructuralist view. And specifically, if we identify element, and which we do with atomic number, then we can say that atomic number is a necessary and sufficient condition for being an element. But we do know that the case is not as simple as that. Sorry, there's some error, but sorry. Okay, but then we do know that phenomena of especially isotopy and allotropy, they do present a problem for microessentialism of chemical kinds. For chemical kind element. Specifically, when we say that are two isotopes of an element the same chemical kinds? Do they belong to same chemical kind element, or they are different chemical kinds? And likewise, we can ask the question about allotropy. Are two allotropes of one chemical element same chemical kinds, or they are different chemical kinds? So this poses a problem for our macrostructuralist account, macroessentialist account, and it poses a problem whether our element is has a microstructure or not. Now, this question has been answered in a certain way by proposing dual sense of natural kind. The idea that element has a dual sense is not new. From antiquity, different scientists and philosophers have been advocating this view, and it was advocated by Mendeleev. And the idea is that, and recently Sherry, or I think Sherry has been advocating this view for a long time now, and Henry has also made use of this idea. And the idea is that we have two different views of element. One is that element which is permanent and which remains even in all chemical changes, and then there is another view of element which is a single homogeneous substance available at in laboratory. So this actually this distinction between two dual senses of element was properly described by Bennett, and as his terminology is translated, he named two different senses as basic substance and simple substance. He defines basic substance as the indestructible substance present in compounds and simple substances. And he defines a simple substance as an isolated basic substance uncombined without other when that uncombined basic substance is available to us, to our senses. Sorry. Okay, so it means basic substance is an abstract, indestructible. It is abstract, indestructible, and it acts like more like a principle. And for instance, in chlorine, chlorine as an element is also present in gas, chlorine gas, and also present in sodium chloride. And in both forms, chlorine is basic substance, which is indestructible. Actually, Bennett makes an interesting remark about a basic substance, that it is qualityless. So the idea is that it can contain qualities and a wide range of qualities, but it is in itself qualityless. He also characterizes basic substance as transcendental. I think all these views are definitely questionable. And on the other hand, simple substance is something is a variant of basic substance which is available to us in laboratory. It is whatever is observable, or whatever is available to us in physical form. Now, basic substance as transcendental, I think that, of course, that view is overly complicated, and it is contradictory as well. The view that a basic substance has qualities and it does not, it contains qualities, but it is qualityless. Of course, yes, we have an answer that it may be characterized as bearer of properties, but I don't think that is a very good explanation, because again, it again, the concept of basic substance remains paradoxical. So and is it really wise to claim that the bearer of property has a different metaphysical existence? And definitely it makes the whole concept of basic substance very mysterious. But one thing which is important for Peneth was that at least there is one property which is related with that basic substance, and that is its atomic number. Sherry has actually developed this idea, this concept, and the way he has developed this concept has has provided a better concept of basic substance. So of course he stays away from calling it a transcendental view, so his view is less mysterious, and he introduces a third concept, which is called combined simple substance. The combined simple substance is that a simple substance which is actually which is present in a compound. In other words, element when it is present in a compound is called combined simple substance. So on the one hand, at the fundamental level, we have basic substance, element as basic substance, and at the level of laboratory we have or at the observational level we have simple substance and combined simple substance. Now such a modification has its merits. First, I think it actually it works very well for the idea that a periodic table is not only a periodic table not only represents a basic substance, but it represents simple substances as well.
Excuse me, Safia, you have 10 minutes more.
Yes, okay. So it means periodic table actually refers to or represents all types of elements, all forms of elements, whether it is in compound, whether it is in simple substance. And another aspect of this modification is that it explains, because it includes all different versions of element in the periodic table. So it explains why not only that elements are categorized in according to their atomic number, but why they are in groups or in periods. And for most, it actually works very well with even Pennett's idea that there is an epistemological difference between the basic substance and the simple substance. Now, does this distinction actually solve our problem of isotopy and allotropy? Yes, it does. So it works like that basic substance, actually isotopes are basic substance. As basic substances, isotopes actually are same chemical kinds, and likewise as basic substance, allotropes are same chemical kinds, and that's why two allotropes actually are connected with one single element. And this also is the case because I think in the in the case of isotopes, they are almost chemically same. But I think that does not solve our problem, because even though we can claim that this solves the problem of isotopy, but I think still the problem of allotropes is not solved. Why? Because the basic concept does explain why two allotropes are same, but it does not explain why they are different. And I think this is a very important question, because not being able to describe the difference between two allotropes is a huge problem, because it actually makes the explanation deficient that why they are similar. I mean, just by saying that they belong to same category would not work if we also not answer the question why they are different. So I think this makes the whole explanation incomplete. And explanation is also incomplete in the sense that we have not defined what is atomic number. And so these problems can be solved by an obvious solution, though I think that obvious solution is appealing as well, and that is the macrostructural explanation. So macrostructural explanation works with this distinction and claims that basic substance and simple substances, they have microstructures, and that actually solves the problem of allotropy as well. But Sherry has actually questioned macrostructuralist account, and he claims that there are certain problems with macrostructuralist account. First, that the distinction between basic and simple substance and macrostructuralism and anti-microstructuralism is very different. They are quite independent debates, so they don't have anything to do with it. And even there have been many chemists who believed in such distinction, basic and some simple substance, but they were not, they were anti-macrostructuralist, or they didn't believe in atomic theory. And second, that he claims that atomic number can be defined by, because it is measured by a spectroscopic technique, so it can be taken as a tool of measuring element or identifying element, rather than something which is represented by a certain atomic category. And he thinks that we can even use the term elemental number instead of atomic number. And also he has, I think this is a very important claim, important criticism, that he thinks this whole account leads to reductionism. So in a sense, we should present a version of element which is non-reductive. Because it should be able to explain the macroscopic substances as well. And I think he also considers the traditional problems of macrostructuralism as important as well. Now, I think as to his first argument, that the two are independent distinctions, but that does not mean that they cannot be related. So the claim that there were chemists who didn't believe in atomic theory and still believed in this distinction actually is not a very good claim, I guess, because
I guess the connection of Safia, it's been worrying. Okay.
Does someone have her email address? Maybe we could send her an email.
Yes, I'm already writing to her, but
Okay, great.
this is a very bad luck for today.
She might not be able to connect to email. I don't know.
Yeah, because what I'm going to ask her is for her slides, and maybe that will make her easier to speak and not lose internet connection, and I can project the slides.
Right, okay. Let's see if she comes back. If not, maybe we could start with the questions, and we'll try to take notes and summarize the questions to her if she does manage to come back.
Yeah, I guess that's also an option. If anybody has any questions, you are going to be recorded, and I can give her access to her recording, so she can find out what you thought of her presentation so far.
So Alejandro, would you like to field the questions if anyone has them?
Yes. So, okay. Anybody has a question? Okay, Eric, please.
Well, first of all, I'd like to thank her for all the attention that she seems to have given to my writings on this over the years. One specific question I would have for her is she claims, or she says that a problem with the view is that allotropes are different, but that the view does not support that fact. I would like to propose that she can strengthen the criticism, maybe, by saying that isotopes are also different. I mean, why not seize on that fact? I mean, as much as isotopes are different, allotropes are different. Where's the problem? I wish she could come back. Maybe I should just wait, and it's not fair to be asking these questions in the ether. But interesting paper. Of course, I would say that.
Thanks, Erin. So for the recording, anybody has another question?
Klaus, did you have any view on this? You've written a lot about element.
Yes, of course. I would say there is no need for two notions of elements. That's first. And my question would be, is the atomic number a chemical property? I don't think so. So I would like to thank her, of course. Nice talk.
Did she make that claim that you're referring to? Whether it's an atomic, chemical or physical property?
Okay, so we have the question of Eric from Klaus and Gustavo, please.
You mean me? I am Gustavo.
We can hear you, yes.
In my opinion, a reason for confusion is calling the element a substance. In my opinion, element is not a substance, but it is a component of substances. If we saw the problem of allotropes vanishes, because allotropes are different substances. Two substances are different if they differ by any property that may be composition, that is a kind of elements that are included in it, or even simply because of structure. So two isotopes are two different substances because they contain the same atoms but are in different structures. Also, diamond and graphite are two different substances because they contain the same elements, in this case carbon only, but arranged in different ways.
Thanks, Gustavo. Hi, Safia. While you are coming,
I'm completely sorry. I'm sorry.
Don't
Can
worry.
I continue?
While you are coming back, we have the question round for the recording. So you can, Maria, you have something to say? Okay,
so
sorry.
You can continue. Alejandro, can you make her a co-host so she can share her stream? But what Alejandro is saying is that by the end of the meeting, I'm going to give you access to the recording so you can check out some comments that you received in between. We were waiting for you.
Okay.
Good. So I think you're ready. Can you share your screen? And do you want to share it, or you want me to share it so you don't use that much of your internet?
No, it's fine. It's fine.
Okay, good.
Okay. So, okay. Okay. Yes, and I think atomic explanation makes it less mysterious. And yes, I did that. I already covered it. Yes, and I think taking atomic number as with its heuristic value, I think it's taking away I think it's taking away the explanatory of strength of atomic number. On the other hand, there are certain merits of microstructural explanation. For instance, it is very rich explanation, and it has, I think, explanatory success, which is, I think, which is phenomenal. And besides, it gives us a better explanation of allotropes as well, that why two allotropes are different. The microstructural explanation works like that, basic substance and simple substance are macrostructural. So basic substance has macrostructure in the form of atomic number. So yes, it plays its part as the identificatory element, as the identificatory aspect of element, because it has a certain atomic number. And so at the level of atom, basic substance identity works at the level of atom, I think. Whether it is in the form of simple substance or combined simple substance, it is the atomic number which retains the identity of basic substance. And that's why basic substance, yes, it persists in chemical change because it represents that atomic property or that atomic structure, number of protons. And when we combine a macrostructure with a basic substance, then I think it also tells us why two allotropes are different from each other. Because actually, two allotropes are different from each other. They are same because they belong to same basic substance, but they are different because their molecular structure is different. So molecular explanation actually takes us a step further than basic substance explanation standalone. There is another merit of macrostructural explanation, and that is, I think it goes very well with Sherry and Bennett's idea that there is an epistemological difference between basic substance and simple substance, because it means that at the very basic level, the microstructure is represented by atomic number, and at the superior or at the higher level, that is not represented by one certain category. Does this solve all the problems? No, of course not. And specifically, we must understand that yes, Sherry's biggest issue with macrostructuralism, which is its reduction to quantum physical explanation, is not answered actually. And specifically, this is not answered because I think because explanation, of course, does not stop at the level of atomic number. It goes beyond that. So I am still actually thinking about this issue, and my mind is still not made up about how to tackle with this issue. Please do tell me how. But I do, at least I claim that we should not actually reject macrostructuralism because of that. Because rejecting macrostructuralism means that we are bypassing the main question, and that is what makes basic substance. I conclude that by establishing the macrostructural view of chemical kind element, we can say that placeholder essentialism, those dispositions, intuitions, they do play a certain role in our chemical categories, and probably scientists do ask the question of nature of elements, natural kinds. Thank you.
Thanks, Safia. So as Maria said, you can see or you can check the questions and comments that Eric, Klaus, and Gustavo made for the presentation. So before we say goodbye, more or less, I shall give the floor to Maria.
Yes, no. We have still time for a brief Q&A. So if anybody has a question, now that Safia has come back, can you raise your hand? As I said before, reactions, then there you are going to see raise hand. Or Eric, raise it in person in front of your camera. Eric, please.
Thank you very much for your presentation and for giving so much attention to what I've written and for what other people have written on this. Are you familiar with the recent book, What is a Chemical Element? A collection of, I can't remember, 12 or 14 essays on the subject?
I have seen a few chapters, but yes.
Okay.
No,
Okay. I'd be happy to send them all to you. Okay. It will give you, more material to play with. You've certainly shaken up this debate. I have to say, you've kind of chopped it up in different ways that I certainly hadn't thought of before. So thank you very much. Thank you very much. One small question, which I did ask, but it would be nice to ask to you directly. When you say that the view that I've proposed doesn't distinguish between allotropes, are you saying that it does distinguish between isotopes but not allotropes?
No, it does. Yes, I think because as far as I remember, because I think you have said that isotopes are almost chemically same, hence they belong to same chemical category. So in the terminology of natural kinds, we can claim that they are same natural kinds.
Okay, but then
allotropes are different chemical kinds because they behave differently.
They behave differently. But I put it to you that isotopes also behave differently. Doesn't that present a problem? Isotopes have different masses. They have different properties. So they behave.
But we are specifically referring to chemical differences, isn't it? Because chemically they are almost same.
Okay. Well, then that's the key. Why restrict yourself to chemical properties? Why not, boiling points?
Yes, that is a question that I think that is very important question. But then again, I think for that question, to answer that question, we have to go back to at least I think Bernstein paper, 2014 paper. I think she makes a very good argument that chemical reactivity actually sets the stage for us, isn't it? That because it tells us that how we categorize, this is the sphere that we have to deal with chemically.
Yeah.
Though I do understand there are so many problems with that.
Okay.
But
I would be delighted to continue this discussion. I'm sure there are other questions. Thank you very, very much. Excellent paper.
oh, thank you.
Gabriel Vancic, please.
Yes, just a short comment. Isotopes are chemically different. This is very well known from kinetic isotope effects, because if you put deuterium instead of hydrogen in some molecule, the reaction can be even 5, 6, or 7 times slower than with hydrogen. So that means they are chemically different.
Yeah. And it's difficult to draw the line. Spectroscopically, they're different. You know, if you have an OH bond as opposed to an OD bond, the frequency is altogether different. And where are you going to put the line between chemistry and physics? This is the constant problem that we're up against. This is what I was saying to Klaus in the time when you were struggling to come online again.
Yes. Yes, I completely agree.
And biochemically, you know, heavy water apparently kills fish, whereas real water or H2O water doesn't kill fish.
But then there is an argument that, again, are biochemical kinds, chemical kinds.
Well, we had a speaker about that a couple of days ago.
Yes, and I think she made a claim that biochemical kinds should be considered a very different category and should not be reduced to either chemical kinds or to biological kinds.
Yeah.
Michelle has sent Safia a couple of questions through the chat. So I don't know if you want to address them now or...
They were the questions that were asked while you were away. So they're just a summary of questions that Eric and Klaus and Gustavo asked.
And I think something that we can agree to do is that by technical difficulties, we can record them apart, and then we can add the Q&A when we are editing, so we don't have either to miss your talk, for instance, or to have to put pieces together, things like that. So I'm going to send you an email about this, and maybe we can record them on Saturday or Sunday, that are days that we end up before. So, but that would be a good, the same for Moises. You are so welcome. I understand that going back from this thing are difficult and challenging emotionally, and so it doesn't matter. And I'm going to let you see the questions. I'm going to send you an email with the link. Thank you, everybody. If there are no more questions for Safia right now, thank you for staying this extra minutes. We are really happy about this session, which is only the third of 7 in total. So we hope to see you tomorrow morning.